Hello and welcome to day 30 of daily Leetcode challenges. Let's begin our daily question. Question 438. Find all anagrams of a string. Given two strings S and P, return an array of all the starting indices of P's anagrams in S. You may return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. This is pretty much a permutation, I believe. If it is, then the question will be very similar to the previous one where we had to find if some string, if S1 contains some permutations of S2. Except here, we will not be returning a Boolean true or false, we could be returning the index of that beginning permutation. Let's look at some inputs to get a better idea if that's actually what they're asking. Input S, C, B, A, E, B, A, B, C, and the P, or the string that we're trying to permutate, is A, B, C. And that's one permutation, and then 2, 3, 4, 5, 6. BAC is another permutation. Substring, anagram, BAC, which rearranged. Okay, so this is one-to-one with the previous question. I'm linking the example or very similar question in the video above right now. Let's begin the same approach. We're going to have two hashable or two comparable data structures that can be compared with O1. And what we're going to do is have a sliding window on S of size P and basically slide it along to the right. And each slide we're going to see if that data structure is, or that hashed data structure is equal to P. Now, what allows us to make that comparison is that no matter the order of characters inside of the window S, the hashed structure is going to be equal to P regardless of the order if all the letters are present that are here in P. And so let's call these two data structures are just going to be arrays of length 26, where one is named RS and the other named as RP. Then we're going to populate both of these data structures that we're using as sort of like hash structure. We're going to say that RS of, let's see, S ord SI minus ord A. So what we're doing here is, this is actually RS and RP are representations of the English alphabet, of the lowercase English alphabet. So it has 26 values, and each of them is going to be representing a character, A through Z. As we iterate through our string, we're going to increase the number of occurrences of that letter in the representational. So it's basically like a counter. And the reason why this is important to us, and the reason why we do that is we're going to be comparing purely the number of occurrences of characters with P and a certain window of S. Let's see, why is this screaming? Slice. Why is it screaming? I'm saying that I need, I don't know why I have this. I don't need, I just need the order of S minus the order of character that we're currently looking at minus ord of A. There we go. I don't know why I had that extra two letters in there, but perfect. So now that we've made this comparison, we're going to, or we've initialized both of our two counters essentially. We're going to implement the sliding window. The sliding window is going to be in range of where we left off, which is len P, and what we're aiming towards, which is len S. And we're going to say that RS, which is going to be our sliding window counter, is going to increase the next character that we're looking at, which is going to be ord. Same thing. Ord SI minus ord A plus equals 1, and we're going to decrease the counter for the character that just exited our scope, which would be S minus len P. I have that extra in there for some reason. A. 1. Mm-hmm. There we go. These parentheses always get me. This is ord. This is the thing that we need. There we go. Let's make this more legible, but what we're doing here is we're adding the next character that enters our scope of the window and removing the previous. And now all we have to do is say that if rs is equal to rp, then we're going to say index, and this is going to be answer append I. Answer append I. Let's do the same thing here. If r, let me just copy this pretty much. R, and let's have an answer array, and let's return ans. Wrong answers, but let's see. Okay, wrong answers because this should be 0. How did that even initialize? Because we are comparing the start instead of the end, and this can be actually I minus len of P, because the I sort of represents the end of the window that we're at, but we need to be looking at the beginning. Let's submit this. Sorry, run. Still wrong. Still wrong. Okay, wait, hold on. Why? Can I just do -1? No. Nope. Sorry, +1. I might be like some weird offset might be of S. Is this another instance where S is for some reason smaller than P? I think so. Let's say that if len P is bigger than len S, return this. Submit. Sweet. Okay. Awesome. Yep. Very exactly the same question pretty much. I'm linking the video to watch right now. Cool. I think we're at the top of the chart again, so there's no point in exploring pretty much different options, but here's the solution. The format identical to the previous one, so definitely watch there. Cool, thanks for watching. Bye.